Hi everybody, my name is Hannah and this is Pepper and Pine, and I have a mineralogy lesson to share with you today. We're working through our Waldorf Live Education curriculum, and today we're going to be exploring iron ore through igneous rock formations. So this lesson is a complement to the previous lesson that we did on limestone and on chalk and sedimentary rocks in general, but very specifically on limestone and how we can extract concrete, cement, and mortar from limestone, which are used in building materials. So today's lesson is to look at igneous rocks and specifically granite and the extraction of iron ore from granite, which then produces steel, which is another building material. Now, in doing the research for this lesson, I realized that more likely our iron ore is coming from sedimentary rock formations rather than granite formations, although it still is possible because iron ore can be in different kinds of rocks. But I went ahead and found this illustration to show how iron ore comes from igneous rock and specifically granite. Now, as I'm drawing this, I realized that probably this illustration is showing iron ore from sedimentary rock. And I don't realize this until nearly the end. And so I'm going to pivot the lesson at the end to then include another illustration, which you'll still be able to see. Now, in doing these lessons, I am preparing a few days in advance of presenting these lessons. So I'm doing the illustration before I present the lesson, and then my daughter can copy that. And then I'm also preparing the content for the lesson in advance before presenting it. Now, I didn't do this in the past. I don't typically do this. This does require a lot more time and effort. And when I was homeschooling multiple children, I just didn't have the time to prepare for lessons the way I am now. I am down to just homeschooling one child, and so I have a little more time to focus on these lessons. In the past, when we did our mineralogy unit, we did it as an earth science unit or as a geology unit. And while I had the curriculum, I didn't actually use it. I ended up dispensing with the curriculum early on because I didn't really understand the direction the curriculum was going in. And it seemed a little bit confusing for me. We ended up using a lot of our books and other resources instead of using the curriculum. Now that I'm down to just homeschooling my last child, I wanted to use the curriculum as closely as possible and really explore the main lesson block of mineralogy, which does have its subtle differences from earth science and geology. So in doing so, I need to prepare a lot more and have a better understanding of these lessons before presenting, because in the past I could just use the books that we had, read through them aloud, do the projects, and that was sufficient. So in researching iron ore, I found that since it's more likely from sedimentary rock, I needed to pivot the lesson, and you're going to see that because the illustration on the adjoining page, which really should have been the written portion for this lesson, is going to show another illustration that more specifically shows iron ore being produced through igneous rock formations and volcanic activity. This illustration shows a cutaway from a cliffside. The top of the cliff has these tiny little trees to show scale because this is supposed to be something quite large. And then it shows the veins of iron ore, the bands that are on the cliffside that are exposed. Then the cutaway shows those veins going at an angle that are within the cliffside. So through tectonic activity, earthquake activity, other geological forces, these bands that were underground then come up above the ground, either through tectonic activity or through the process of erosion. So here you can see that there are other factors involved in the veins of iron ore being exposed. That could be weathering, that could be water activity, plant activity, animal activity. And so when the water is going through these structures, these stone structures, it's cutting away at the cliffside to expose these iron ore veins. So with the water, you have the breakdown of these larger rocks into smaller rocks and then into smaller grains. You have, through the freezing and melting of water, you have big chunks of the cliffside that can break apart and end up at the bottom of the cliff. And then through animal activity and plant activity, you can see further breakdown of the cliffside. So I went ahead and I just added a little bit more illustration to the back of the illustration just because I didn't have any more written content for this page. I just have a few captions, and I do end up titling it Iron Ore from Sedimentary Rock because I think that this illustration more closely depicts iron ore from sedimentary formations. So now on this page, rather than doing the written portion, which I have been doing a narration, not just so that my daughter could copy it if she chooses, but also to collect my thoughts in preparation for the lesson. More often than not, she is writing her own narrations, and I prefer her to do that whenever possible, especially for this kind of content where it really needs the processing and the understanding, and I don't want her to rely on just copying the information. I feel like that's not going to be as helpful in her understanding of these lessons. So for this illustration, I searched a little bit more online, and I found this illustration of iron ore being produced through volcanic activity, and I believe that this particular illustration depicts a very specific volcano, and I think that these illustrations have been produced by either scientists or geologists or investors so that these iron ore deposits can be mined, which was a completely new rabbit trail that I went down in doing the research for these lessons. I learned that anything that isn't grown that you're using is probably mined, and that was completely different from all of the geology that I had been learning and teaching so far, which really had to do with land masses and nature and the beauty and the history. And now we're looking at something that's economical and in a lot of cases quite political as well. So those lessons are going to be saved for another time, probably a completely different main lesson block, because those are quite important to understand, but not part of this particular lesson at the moment. So the magma chamber below the volcano is quite large and extensive. What I learned recently as well is that even though magma is fluid, it is a very thick fluid that in a lot of cases, because of the depth that it is under the earth and the pressure, ends up being a solid rather than a liquid. But as it moves to the surface and the pressure goes down, it becomes liquid quite rapidly. So that was a very interesting perspective on understanding these geological phenomena. The other thing that's important to understand is that while there are an abundance of minerals within magma, it really depends on the surrounding rock and the presence of water as to which minerals are going to precipitate out and how they're going to precipitate out. So you can see that in this illustration, I have included some of those particles to really show that process of precipitation and the whole process of the iron ore production through volcanic activity. I hope that you're enjoying these lessons. You can check out the complete blog post that includes all of the resources that we've used for our geology, mineralogy, and earth science main lesson blocks over the years. You can find that link down in the description box below. And if you'd like to see how we're homeschooling on a daily basis, you can find me on Instagram at Pepper and Pine.